we are actually presenting our Fundamental of Computer Network assignment, which is BAIT 2004. I'm Lim Cheng Chen. Another member of mine is actually Kek Jia Hao. So what we will actually go through is actually the scenario, network topology design, IP address, the process implementation process of the network, and the pin demonstration. So the scenario is actually very simple. It's actually we are hired as a LAN engineer by this company, Equate Go Logistics, Sdn Bhd. We will actually design 4 subnet, which is location A, B, C, and D. So for the biggest subnet, we actually the biggest and the second largest subnet, we need to actually add in the 10% growth as well, so which I will show you later on. So you can see actually our network topology design, we're actually utilizing a star type topology. All the network is basically connect to a central device. Typically, it's the switch and the router as well. So the end device like PC and laptop, they have a dedicated cable connecting to the central switch as well. So when they want to connect, they will actually send the message to the router and forward to the destination. So in this star topology, the inside the local area network is actually much more reliable, and that at the same time, right? Even though one device or one subnet is down, another is actually still ongoing and performing as well. And this network topology is much more easily scalable and expands seamlessly without affecting the other device as well. The VRSM, basically, it is more efficient to allocate the IP and then compared to the FLSM. So the VRSM, I basically divide the subnet into a various size and reduce the wasting of the resources and the address space as well. Easily scalable and more flexibility. So we will see as actually, for example, the highest host to the lowest host. Let's take, for example, location A. What we can see is actually there's 44 hosts after the 10% growth. So for subnetting, basically we will need to use CIDR or the prefix 26 because it will provide 64 number of hosts, which is suitable for our 44. So the nearest one is actually the 26, which will be the subnetting mask, which will be 255.255.255.192. And the next one, what we will go through is actually the subnetting table, which you can see due to the time issue. So I'm just going to take location A as an example, because if not, then the time will be insufficient. So for example, you can see in location A, you can actually see the subnet address, the first usable hole address, last usable hole address as well. So first usable host address is basically we +1 from our network address, which you can see, which is 192.168.1.0. So after adding +1, then it will be our first usable hole address. The last usable host address will be calculated by -1 from the broadcast address. You can see on the screen that broadcast address is 192.168.1.63. Broadcast address is actually the last address of the IP network, so which is actually on the screen. So the default gateway, which I will show you later, over here. Okay. The default gateway basically is actually known as default router. So when the destination is unknown, they are the one which will be sending to. For example, the location A, the switch operation is actually, which you can see is actually from here, which is actually from what we can see the address as well. The location A, switch operation, SW01, connect to the interface, GI0/0, and the IP is 192.168.1.1. So the default gateway will be the same. And the next one, what I will be explaining is back to this network topology. So what you can see is actually from the location A, which is the light blue color up on the top left, is actually the location A, which we use 2 switch, and the PC 1 to 4 each will link to one of those switch. and the cable that actually we're using is copper straight through to link, and at the same time, the connection port, we utilizing the fast Ethernet capability. So both switch connect each other using copper crossover cable to fast Ethernet port. And for the location B, you can see the host is 36 hosts, and we are using 3 access switch. So each switch is actually paired with 2 PC to efficiently operate. So the HR switch is basically connect to the PC7 and 8 for seamless connectivity, which is very, very important because location B is actually support day-to-day operation for the business. So in this location B, beside the HR, they have the account department and the warehouse department as well. PC and the connection between PC, we're actually using copper straight through cable and switch to optimize the data flow. So in between the HR department, the account department, and the warehouse department, the switch interconnection, we are using copper crossover cable with fast Ethernet. So this will actually enhance the network capability and easy to manage for data transmission as well. Let's go to the location D, which is the green color on the screen, which you can see we're actually utilizing one switch. This is a little bit special because we are actually using the fiber optic cable to connect from the router to the switch because it's actually 150 meters away. So it's much better to use a fiber optic cable. Inside over there, the switch copper straight through cable is used to link PC, printer, and the connection port using fast Ethernet as well. So like I mentioned, the fiber optic cable is actually being utilized. Let's go to the last one, which is the location C. The location C is actually contained of 3 rooms and 1 switch. So we are same thing, we're using copper straight through cable on all connection port and are configured with fast Ethernet. So that is actually all from me. So I'll pass to my partner, Kek Jia Hao, to present after this.
Hello, my name is Kek Jia Hao, and I'm going to present the second part of the presentations. So after calculating the subnet address, first usable host address, last usable host address, broadcast address, and subnet mask, we will develop an address table to calculate the IP address of all the devices. So in this address table, it includes device, interface, IP address, subnet mask, and default gateway. We have differentiated the 4 colors for 4 different locations. For all the location, we use one router as our network device and Gigabyte Ethernet as interface. So the IP address and the subnet mask are get from the subnet table. Next, we are using 7 switch for our device and VLANs as our interface. So for the IP address, we use the router IP address +1 and then to get it. For the subnet mask and the default gateway is the same. You can get it from the subnet table. Here we are using fast internet interface for PC and laptop. However, the printer, we are using the network interface card as the interface. So come to the configuration device for switch and router. This one is to configure the host name, and after configure our host name, we configure the password to secure access to privilege mode. And this one is to encrypt our password so that the password will not show as normal text, instead of it will display a random text. And this one is to configure the line passwords. So after that, we will use interface Gigabyte Ethernet for our router, and go similar for the switch also. We use interface VLANs fun, and then enter the IP address and the subnet mask, and then the no shutdown to enable the interface. This one is to configure the mode banner. Before you enter the password, it will prompt the message. So come to the pin connectivity. I'm going to ping the PC randomly. So I'm going to ping the location B PC. It will show request timeout for the first one. It's common because the system need to ensure the PC, the IP address is used, then they will communicate to each other. And then we ping it again. That should be complete. And now we ping the second one for location C. It also the same for the first one, request timeout, and we ping it again. Should be alright. Yeah. So that's all for us. Thank you.